right. Yes, thank you. Welcome to my pitch about RadioLib. RadioLib has a great tagline, one radio library to rule them all. There's a reference in there, of course. My name is Steven. I am part-time teacher, part-time developer. Welcome to my pitch. Welcome to everyone online. And probably watching this back later. So how this project started? That's a while ago. In 2017, it wasn't me who started this. Most of the credits goes to Jan Gromisch. He started in 2017 a library called LoRaLib, specifically focused on LoRa for the SX1270X series. So limited to one type of radio. It was released in 2017 as a pre-release, and in 2018 it was official. And in 2019, Mr. Gromisch wanted to send satellites to space, and they wanted to send the new radio version, the SX1260X, so he had to expand, and well, one thing led to another, and this is where we are now. There's a whole list of supported modules, and actually pretty much every radio that does sub-gigahertz is on there. So we have some old ones or smaller ones up to the brand new, pretty much new LR-11X series. And we are looking to support the LR-2021, which is upcoming as well soon. But all the popular radios are in there as well. So almost all radios are supported. And we also support a lot of protocols. Not just LoRa anymore, but it's also FSK, OOK, LR-FHSS, and then some modules, the 1280X, for example, do BLE and ranging, and the LR series do some Wi-Fi and GNSS scanning. It's all supported. The protocols that we support are also quite diverse. Some very old ones, Hellschreiber, very old technique. But missing in this list was LoRaWAN, and since 2019 Mr. Gromisch had already an open issue on the GitHub page that it should be supported. But it wasn't for a long time. And at this, in the summer of 2023, I was looking to evolve my prototype boxes that use LoRaWAN into this small box that we see here now, which is actually neat. Well, it got here, but that wasn't easy. I wanted to use the new radio, the 1260X, which wasn't supported by LMIC for a long time. LMIC was the golden standard for a long time, but it only supported the 1270X series until a bit more recently. And I also wanted to use the ESP32 series of devices. And the ESP32, if you want to use low power for a small box, it loses its state during deep sleep, and losing your state in LoRaWAN is not done. And that was not supported by LMIC. So I was looking for something new. And then in the summer of 2023, Mr. Gromisch actually added LoRaWAN support, basic LoRaWAN support. He added on one day 1800 lines of code to RadioLib, and that was the foundation for the LoRaWAN support. And I was actually on holiday browsing the internet looking for libraries that I could use on my device when I found this. And I was looking through the code and I can actually read this code. There are lots of libraries out there that are very opaque, very high level, level C++ or, well, difficult to read, but I could actually read this code, and that was pretty cool. Well, the support was basic, but I was like, okay, I can work with this, and we can make this go further. The power of RadioLib was like LMIC only supported 1270X, but the initial commit message was already we supported 1270X, derived series RFM90X, the 1260X, and sort of the 1280X. It doesn't do normal LoRa, but that's because RadioLib is a very abstract library with respect to talking to the radio. So there's a general method to set a frequency, to set a data rate, and they are all implemented in a driver specific, in a radio-specific driver. It's a very abstract layer in between, so that means that if there is a new radio like the LR-2021, we need to implement the abstraction layer, and it's automatically supported by LoRaWAN, so that's very powerful of RadioLib. So I was like, okay, I can work with this, and I started contributing. Since then, the LoRaWAN stack has been revised 3 times over, roughly. You can see I added 17,000 lines, I deleted 12,000, so that, yeah, a lot of the stuff that I added first saw revision. But I've worked hard, and not only myself. I teamed up with Nick. Nick is one of the TTN forum admins, and he has seen a lot of stuff that people run into. A lot of questions on the forum, all very much the same questions. So we were like, how can we make this good? So that people don't run into the same questions over and over again. He has been testing it all to make sure that the typical problems that users run into are fine. He has made a guide, a documentation on how to get started, how to configure your device on the things stack. There's also some documentation for Chirp stack if you want to use that. And we have seen almost 0 user questions since. Of course, there's the occasional, where's this? And they missed it in the documentation, because there's quite a bit. But the typical questions, we rarely see them. So that's great, and it's been a pleasure to work with Nick on making this good. So where are we at now? What did we make? So we have Class A operation, which is pre-certified on all frequency bands, not only EU and US, it supports all of them. We support Class C operation as well, since a half a year or something like that, including multicast. So if you want to control a series of lights, for example, you can just send one downlink over multicast. And we support LoRaWAN 104 and 1.1. 1.1 is the most secure, 104 is the newest. 1.2 is in the making, we hope to support it as well. But we support the two best ones, as well as the most recent regional parameter versions, with 1.0.4 being the newest, but 1.1b is pretty much exactly the same. So we support the latest and greatest of LoRaWAN. And to get you started, if you want to use it, we've made a bunch of examples. So there are like 7 in total. So we've got a simple starter one, a full reference example to demonstrate all the bells and whistles, Class C and multicast over Class C. ABP, if you want to use that, it's discouraged, but it's there. Packages, for instance, the certification package is in there. And externally, we have also an example for ESP32 with deep sleep, because that's a special one. RadioLib in itself tries to be agnostic of whatever you want to use. So we hosted it externally to make RadioLib completely agnostic. But it's a special use case that I wanted to use as well, and a lot of people want to use. So we have an example for that as well. So if we want to start with LoRaWAN, how easy is it? It can be done in approximately 25 lines of total code. So we include RadioLib. You can do this in Platform.io is the example here. You can use it in Arduino IDE or whatever you want, but the 2 popular ones. So we create a radio, in this case a 1262, with the pins used for that, the IRQ pins. We instantiate our node with, for instance, for me that's the EU band. No subband used, subband 0. You can set the subband if you want to use the US or Australian bands. And then in setup we initialize our radio. We start our node with the required keys. You can copy the keys straight over from the console, the Things console or other consoles. And we activate by a join request and wait for a join accept. This code assumes it joins automatically. There's of course return codes that you can use to evaluate whether it worked. But this is a simple start. And then we have a loop over here. We set up some uplink data, just 2 bytes, 2025, a length of 2. We create a downlink buffer. of size 255. We want to accommodate any size downlink. And we send, for instance, to F port is 1, unconfirmed message. And then we transmit our message. It also waits for the RX windows. And if there's a message on an RX window, well, in this case, in this example, we print how long that message is. And then we can just do a delay, a sleep, whatever you want to do. Anything you want to do in between is fine. And then whenever you want, you can start again. So this is as simple as it can be to transmit uplinks and receive downlinks. And there's a whole lot of extra processing that you can do, all bells and whistles, but this is just a simple demonstration. So why should you consider RadioLib? It's easy, as I demonstrated. And why now? We are here at the Things conference, which is all about not just LoRaWAN, but all sorts of techniques. And RadioLibs give you full control over not just LoRaWAN, but also over the radio. They are completely independent. You can do anything in between your uplinks and downlinks. You can do LoRa point-to-point. You can do FSK. You can do some GNSS scanning with the LR series. And as soon as you want to send a LoRaWAN uplink, the LoRaWAN stack takes over the radio and reconfigures it to whatever is required. But you can do anything in between, so you can use your device to listen for other devices and then send an uplink, whatever you want to do. So it's really flexible. And not only that, we support a lot of frameworks out of the box. The Arduino framework is maybe the most popular one, with all other frameworks that use an Arduino variant, the ESP32 Arduino core, the STM32 Arduino core. We support the Espressif SDK, the Raspberry Pi Pico SDK. You can run it as a native Linux app as long as you, well, we have an example for a Raspberry Pi implementation. You can use it natively on the Raspberry Pi. And it is a minimal portable HAL. You can port it to any framework that you want as long as you implement a few functions like a delay and a timestamp and the SPI transactions that are required to communicate with the radio. You can use anything, any framework you want. You can use any radio you want. So it's really flexible. And not only is it really flexible, there's also a very active community around RadioLib, not only for LoRaWAN. There's Meshtastic, of course, which is the biggest user of RadioLib, which uses plain LoRa. There's MeshCore as well. The LilyGo, for example, use RadioLib in all their examples for all their devices. There's a lot of people that use RadioLib, a lot of projects. And you can see that the activity on GitHub is through the roof. We've been growing and growing. This line marks where I approximately started adding LoRaWAN together with Mr. Gromesh, and it's just keeping growing. So it's really popular, and there's a lot of support around it as well. Specifically for LoRaWAN, we see some support that was added by the community. Persistence handling for the ESP32, for instance, has been added by the community. They contributed to that. First, we were just waiting for RX windows, but community added support for sleeping during RX windows to maximize battery life. Listen before talk has been added as a support, and there's many extra details, small things, frame pending flags, many documentation, mistakes or improvements have been added. So it's not just me and Mr. Gromesh and Nick, but there's a lot of people in the community who are actively trying to contribute. So we would really like you to try RadioLib, try it out for yourself. And then two more things. Not only would we like to try, but also we would ask you to contribute. There's a few concrete things. We are working on certification, but I only have 8 channel gateways myself at home. For a full certification suite, we would really like some 16 or 64 channel gateways, which are required to run the full certification suite. And then we would really like to send some actual controllers to a test lab, but that is quite expensive. expensive, a few thousand euros. So if you want to help with that, that would be great. For instance, if you want to use it in your own device, we can team up. RadioLib does support LR-FHSS. We want to support it in LoRaWAN as well, but we can't get our hands on an LR-FHSS gateway. So if there's any way that you can help us test it, that would be great. And I said Class A and Class C are supported. Class B is not supported so far. I don't have a Class B enabled gateway, so that's also welcome. And Fuota is something on the wish list as well. The infrastructure is there, you can add it, but there's no actual implementation for it yet. So if anyone wants to contribute that, that would be very welcome. And if you can't contribute specifically one of these things, you can help us by just opening pull requests for details, small things, discussions if you want to improve certain situations, issues. We are looking for examples. If people have certain examples where they use it, that would be great. Or guides, anything is welcome. So it can be something tangible like a gateway for us to test, but it can also be something on the GitHub page. So please, we would ask you to use RadioLib, check it out, and join us in our adventure. Thank you very much. About this? Yes?
Will you add support for 2.4 GHz for LoRaWAN? Because it is agnostic, but I tried to find in the GitHub repository, there is no ban for 2.4 GHz for LoRaWAN.
No, there's currently no support for 2.4 GHz. Once again, I don't have a gateway for that, so that's one reason for me that we can't test it. There's no official LoRa Alliance support for 2.4 GHz. There are some unofficial hacks around it, and I would like to check them out. But I currently have no hardware for that, so if anyone can help, we could hopefully get it further, or maybe someone else can contribute if they have the hardware. So hopefully yes, but right now no.
Yeah, deep sleep. How much memory do you need to reserve to be able to do this?
The deep sleep buffer, so they're like the nonces should be saved anytime, but then the session can be saved in approximately 250 to 300 bytes. And the least I know that any platform supports is 512 bytes in RTC memory, so it fits in the RTC memory of the ESP32. So you can pull the session. There's a function in the API to save the session, and then after deep sleep ends, you can restore the session buffer. Any other question? No? Then I would like to thank you once again.